Welcome to this video. I know it's very messy. I tried to explain as much as I can for this problem. For this problem, we're going to have an origin called Jacksonville, and we're going to have a first flight all the way to Charleston, which we're going to call that C, and then a flight from Charleston to Atlanta, A, and then another flight to Birmingham, B. Now for this, we're going to have three vectors based on a question from the origin Jacksonville, which I actually draw them in different colors, although it seems very messy right now, I know. And I'm going to have my Cartesian coordinate system from the right hand rule. X goes towards the right, which is going to be east, so X whenever goes towards the east is going to be positive. Y, whenever you go north, for example, is going to be positive, then it goes up, it's going to be positive, and then down is going to be negative. West is going to be negative, and south is going to be negative. And see how you're not going to have anything, but if you fly from, you fly with a plane, it's supposed to be some sort of z-hat, but we don't have z-hat for this one. So what I'm going to try to find out from the map, the miles and hours is going to be taking us all the way to all these destinations. We're going to have like 3 hours from Jacksonville to Charleston, 1 hour and 50 minutes from Jacksonville to Atlanta, and then 2 hours and 50 minutes on the plane all the way from Jacksonville to Birmingham. And then the miles we actually add up 238 miles, that's what the map tells me, from Jacksonville to Charleston. And then from the map, I find out 246 miles from Jacksonville to Atlanta. And then Jacksonville to Birmingham is going to be 492 miles. Now, if you keep the 15 miles attention from the map, which I'm going to show you in the video right now that we have that, it's going to be 55 miles x hat towards our right. So this is going to be miles for Charleston. And then 95 miles y hat to the north, or to the top for Charleston. And if you do the dot product for this, if you do the cross, not cross, actually, if you want to find the magnitude of this vector, we're going to have the coordinate system, the x hat, miles, 55 miles x hat squared, 95 miles y hat squared. You're going to get 110 miles for the magnitude of z hat. I do not include z hat because I don't have a z hat. Now for Atlanta, if you use your map scale, it's going to give you a negative 100 miles x hat because you're going towards the west for Atlanta, and then 150 miles y hat towards the top, which is going to be positive. Which if you do the magnitude formula for this one, getting negative 100 miles x hat squared plus 150 miles y hat squared, you get 180 miles as your answer. Now for Birmingham, if you get it from the scales, you're going to get negative 200 miles x hat and then negative 145 miles y hat towards our top. So if you calculate that, the magnitude formula, you're going to get negative 200 miles x hat squared plus 145 miles y hat squared, and you're supposed to get a 247 miles as your magnitude. So you get negative 100 miles x hat plus 150 miles y hat for our Atlanta, and then negative 200 miles x hat plus 145 miles y hat for our Birmingham. So then the displacement is supposed to be negative 300 miles x hat plus 295 miles y hat. Actually, I didn't join them. Am I doing it right? Okay, anyways. So, because I have 180 miles and then 274 miles, and using the protractor, I get 37 degrees angle between Birmingham and Atlanta. So I'm going to use the dot product to find what's the dot product for this one. So I'm going to get 180 times 247 times close enough 37, which I'm going to get square miles 9.20 times 10 to the 10 power. And I just realized the problem that I actually was doing it because I reread all the outcomes again. Yeah, this is the displacement vector, which we're going to get by adding both positions, and then we get the positions that we actually added. I also got the dot product because I find out the angle. I just went with it. I saw that I actually shouldn't have done that. But anyways, I done that by getting that, okay, we have our 180 miles and 110 miles, and then we have the cosine of 70 because I use a protractor and get 70. And then I actually plot all these in for a dot product. I'm going to get square miles, 1.75 times 10 to the 10 power. Now, in addition to that, I'm also going ahead and get, adding the two vectors on with the components, the x hat and y hat, I'm going to get negative 45 miles x hat plus 245 miles y hat. Now,
to the velocity for Charleston or Atlanta, I'm going to get the position vector divided by 1 hour and 5 minutes because that is what the flight time is between these two. So we're going to convert, say like 1 hour is 60 minutes, so 60 plus 5 is going to be 65 minutes. I forgot to put my units. Oh god, this is not good. So now that I divide the whole thing by 65 minutes, I'm going to get negative 0.69 miles of x hat over minutes. And same is going to happen to me when I do the y hat. Now why did I put an x hat over here? I do not know. There's a y hat. So I'm going to have plus 3.78 miles of y hat over per minutes. So that's how I'm going to get the velocity for Charleston and Atlanta. If we did one for Charleston and Atlanta, it's going to be easier to find out Atlanta and Birmingham because I have negative 300 miles x hat plus 295 miles y hat. And then we're going to divide that by 45 minutes because that's the flight between Atlanta and Birmingham. So while doing that, we're going to do negative 6.67 miles x hat per minute, maybe divide, plus 6.56 miles y hat over per minute in order to get the velocity for what we have. Because remember, velocity is delta vector, whatever the vector we have. So we're going to say delta x over delta time. So hopefully you guys learned something new. And actually I said delta x and delta y because we have y also as well.